times I, which is 1 times I, or I. Now let's practice a little more with that imaginary number. Square root of negative 81, x to the 6th. Well, we know the square root of 81 is 9. The square root of x to the 6th is x cubed, and that leaves me with the square root of negative 1, which is I. Square root of negative 108 times x to the 7th. I've gone ahead and pulled out that square root of negative 1. 108, the largest perfect square, divides evenly into it, is 36. And it'd be 108 would be 36 times 3. X to the 7th is x to the 6th times x. And now, working toward our solution, the square root of 36 is 6. The square root of x to the 6th is x cubed. The square root of negative 1 is I. That's all outside of parentheses, outside the square root sign. And what's left underneath is the 3 and the x. So I have 6x cubed times I times the square root of 3x. And here's some other types of problems that you'll see on today's work. 3i times negative 2i times 5i. Well, we handle the numbers all together. 3 times negative 2 times 5. And I've got an I times an I times an I, and that's an I cubed. Well, 3 times negative 2 times 5 is negative 30. I cubed is negative I, so negative 30 times negative I is 30I. 7I squared times 6I. Well, that's 7 squared times 6, and then I squared times I is I cubed. 7 squared times 6 is 294. I cubed is negative I. And so 294 times negative I is negative 294I. Here's another example like on the previous page. I to the 42nd power would be I to the 40th, because that's the one that's divisible by 4. And then you got 2 left over, so that's our I squared. And of course, I to the 40th would be 1, and I squared is negative 1. So 1 times negative 1 is negative 1. Then you'll have some expressions that you'll add together. 7 plus 6i plus negative 3 plus 5i. And we handle the numbers together. 7 plus negative 3. And we handle the imaginary numbers together. 6i plus 5i. And it's pretty straightforward. 7 plus negative 3 is 4. 6i plus 5i is 11i. Sometimes you'll be doing subtraction. Be careful to keep that minus sign going. You got 10 minus 4i minus 7 plus 3i. So I'll have the numbers will be 10 minus 7. And then for the imaginary numbers, it would be negative 4i minus 3i. 10 minus 7 is 3. Negative 4i minus 3i is negative 7i. And then sometimes you'll multiply them, and multiply them is simply a foiling exercise. If I multiply the first together, that'd be 7 times 2, and that's 14. If I do the, outside is what I did next. 7 times negative 3i is negative 21i. The insides, negative 6i times 2 is negative 12i. And then lastly, negative 6i times negative 3i. Well, the negative 6 times the negative 3 gives me 18, and I times I is I squared. Well, down there and below in red, we got to simplify that a little bit. I squared is negative 1, and so 18 times negative 1 is negative 18. So for numbers and simplifying, gathering my like terms, I have a 14 and a negative 8, which gives me negative 18, which gives me negative 4. 14 plus negative 18 is negative 4. And then I have in the middle there negative 21 i's and negative 12 i's, and that equals negative 33 i's. Negative 33 i's. And one last set of examples for some problems that, some other types of problems that you'll be doing. You have problems like 5x squared plus 125 equals 0. And yes, we want to take and divide out our greatest common factor, which is 5. So that will leave us with x squared plus 25 equals 0. And I want to isolate the x, so I'm going to subtract 25 from both sides, and then take the square root of both sides. So I'll have x equals the square root of negative 25, and we know now that that is equal to 5i. Next example, 8x squared plus 96 equals 0. Divide our greatest common factor of 8. Subtract 12 from both sides. Then take the square root of both sides to get x equals the square root of negative 12. Square root of negative 12 is the square root of negative 1 times the square root of 4 times the square root of 3. Square root of 4 is 2, square root of negative 1 is I, and it leaves me with the square root of 3. And there were a couple of people yesterday that asked me about the problem that ended up being b squared minus 9 times b squared plus 9, and they knew they could factor the b squared minus 9 into b plus 3, b minus 3, but they wondered if they could factor b squared plus 9. Well, here's how we do that. B squared plus 9 equals 0. Subtract 9 from both sides, take the square root of both sides, and b equals the square root of negative 9, which is 3i.